All right, it's Mr. P. with Algebra. This is Unit 2, Topic 3, Lesson number 5, and we are graphing inequalities still. All right, so we're given this is the boundary line to this equation. So this starts at -4, and it's going up 1 for every right 5. So you can see that it follows the slope. So that means that this line is the same thing as this equation, but then it's an inequality. So it says less than. So we're supposed to pick a point and then test to make sure that that point is a part of the solution set. Now, I could pick any point on this graph, but the easiest one for me to pick would be 0, 0. Because 0, 0 is going to be very simple to solve. If I put 0 in for x and I put 0 in for y, that means 0 is less than or equal to 1/5 times 0 is 0 minus 4. Now, is 0 less than or equal to -4? Nope, that is not true, which means 0, 0 is not a solution to this inequality. So if this is not a solution, then we know everything that's on the opposite side is a solution. You might also know that anything that's less than, I might have already taught you in class, means everything below is shaded. Don't think of it as left and right, because left and right will depend upon whether or not the linear line is going up or down. So you can't just say that it's left side or right side. Unless it's not a function, it goes straight up and down. That's the only time you want to think of it as left and right. So if by some chance it comes to something that's not a function going straight up and down, then the left side is less and the right side is greater than. Okay, so this one says greater than, so it should be on this side because that's what's above the line. But I'm going to test it anyway by putting 0, 0, and if I am correct, that should not work, because we know this side should not be the side that works. So I put 0 in for y is greater than or equal to -3 times 0 is also 0. Add 5 to that. And you get 0 is greater than or equal to 5. Now, like I said earlier, that does not work. So that means I was correct, that everything on the opposite side is true. So there's your answer there. Okay, so once again, greater than means everything above the line. Don't think of it as left and right. And less than would be anything that's below the line. All right, so once again, we are going to be graphing inequalities. And we have now been introduced to 4 constraints. Space, startup costs, which we did in the first 3 lessons. Now, feeding time and pampering time. So all of these are going to be graphed. And you're going to get to see what they all look like. Now, this lesson starts off with some questions that you had done in the past. So it's really a review of the first 4 lessons. So if you remember writing the inequalities for startup cost and space. So if x represents dogs and y represents cats, always need to have a let statement when writing equations and inequalities. Startup costs happen to be 20... Ooh, I can't remember the numbers now. So I believe it was $80 per dog plus $32 per cat pen, and that had to be less than or equal to $1,280. And then space was, wow, I'm pretty sure it was 6 per cat plus 24 feet per dog, had to be less than or equal to 360. I'm going off my memory here, so if I was wrong on one of those numbers, I apologize. All right, so find at least 5 combinations of dogs and cats that would satisfy both constraints. So we did that in the first couple of lessons. There were some numbers that you could put in here that would meet exactly for x and y and meet this, or exactly in here to meet this. But there was no numbers that's going to meet both the criteria. So when it says find at least combinations of cats and dogs that satisfy both of the constraints represented by the system of equalities. So what we're looking for is nothing's going to be exact, but there is a lot of different answers. I almost said infinite, but that's not true because it's a discrete question. It's not infinite, but there are a lot of answers like 1, 1, 2, 2, 3, 3, 4, 4. And you don't have to be so obvious about your answers. There are going to be some things like 10, 10 is going to be pretty close, but it's going to meet the space and it's going to meet the money constraint as well. So those are some of those answers we talked about in the past. Finally, these 5 combinations of cats and dogs that satisfy one of the constraints. All right, so you can go back over lessons 1, 2, 3, and 4, but I do have one off the top of my head. 60 cats would work for the space. 60 cats and no dogs. So that's like the y-intercept. So if there was no dogs, this would be 0, plus 6 times 60 makes 360, and that is equal to this. That works. That works for this constraint, but 60 times $32 is way more than $1,280. I don't know what that is off the top of my head, but I'm 99% sure it's more than that. So it meets this criteria, but does not meet this criteria. Okay, so that would be an example. I'm sure something similar to that. There's lots of different answers you could have gone with. I'm just trying to give you an example of one of them. So the next thing we're going to do is going to get into graphing the equations. But instead of going to this graph and you're graphing all four of the constraints here, I'm just going to simply go to the solution, which I thought I had plugged in here. So apparently I didn't. Let me see what I did with it. All right, so I'm just going to have to do something I wasn't planning on doing. So I'm just going to go to lesson 12 here for a moment, because I know the graph is here. Here it is. So going through here are all four of the constraints. And you can see that they were all less than, because they had to spend less time for pampering and less time for feeding and less than the startup fee. Everything was less than. So that's the reason why the yellow portion is the answer, because the yellow portion is the only portion that is below all four lines. Like this space right here, if I put a dot right here, which that looks like 28 cats, 4 dogs, that dot right there meets the startup cost constraint, it meets the feeding constraint, it meets the space constraint, but what it doesn't meet is the pampering constraint. Because you can clearly see the purple line is not, it's below that dot. So therefore, that's not enough time. They don't have enough time to pamper the dogs at that position. Same thing goes for something like here. If you put a dot right here, and I know it's very close, but it's not going to meet the startup cost. So now it meets the pampering, but it doesn't meet the startup cost constraint. It's going to cost too much money. I know it's very close, and maybe they can borrow the money, but we have to assume that they're not doing that. Same thing goes for like a point over here. That would meet all of the constraints for pampering and feeding, but it's not going to be enough space, and it's also not going to have enough money for the startup costs. Okay, so let me go back. So that's a brief overview of what this graph should look like, but that was in a one-quadrant setting, because if you think about it, all the negatives don't make sense, because you can't have negative dogs or negative cats. That just simply doesn't make sense in the context of the question. All right, so getting to the homework. Write an inequality represents the shaded region. Write the inequality for the given shaded region. So now they're giving us the graph, and we're being asked to write the inequality. First thing I need to find out is what's the equation to the boundary line. So I need to look closely, and it looks like it's crossing at 7. So it looks like 7 is the y-intercept. The slope looks to be going down 1 for every right one. Down 1, right 1, down 1, right 1. Yep. So that looks to be true. So that's negative 1x. So negative 1, because that's the slope. It's going down 1 for every right one. Well, that's the same thing as that. Okay. Now, everything is shaded below, which means y is the answer, has to be less than or equal to negative 1x plus 7. So if that's the boundary line, the answer has to be less than or equal to. Now, we haven't seen this a whole lot, but if the boundary line is dotted, that means the boundary line is not a part of the answer. So therefore, it would have just been less than. But that didn't happen in this case. In fact, both these boundary lines are solid lines. They're not dotted lines. All right, same thing goes over here. So the first thing I'm going to do is find what's the equation to the boundary line. It looks like this time it has a y-intercept of negative 4. It's got a slope that, I got to look at it closely. It looks like it's going up 2 for every right one, up 2, right 1. Yep. So up 2, right 1 means it has a slope of 2x. So 2x minus 4 is the boundary line. And then the answer is above or equal to that boundary line. Okay, thanks again for watching, and please subscribe if you haven't done so already. Have a great day.